Hi, I'm Stefan Eeskens. I'm an Azure specialist and a Microsoft MVP. I have a particular interest for artificial intelligence. I have been involved in several AI-related real-world projects in the past 3 years. Therefore, I want to share some lessons learned and of course some technical bits with the community. Please follow me on Twitter, as I'll keep sharing extra bits and I'll be announcing the upcoming of new episodes. This course is made of multiple episodes, and some of them might not be recorded yet by the time you watch the current episode. The course explains some fundamental AI concepts and will slowly increase in complexity with real-world examples and concrete business scenarios that could be relevant to your enterprise. You will learn how to create and consume Azure Cognitive Services, as well as how to educate more advanced services and specialize them to fit your specific needs. No technical prerequisite is necessary, as I will try to be as exhaustive as possible in my explanations. However, the course is primarily intended to developers, but part of it is accessible to non-developers as well. In this episode, I will draw the AI landscape of the Microsoft ecosystem. I want you to be a little more familiar with fundamental topics such as machine learning, deep learning, and natural language processing, which might sound a little bit confusing for many developers. Once the high-level concepts will be covered, I'll introduce you to Azure Cognitive Services, and I'll try to quickly answer the "what's in it for me" question, or the real-world examples mapped to the various services. If you're a hardcore developer, you might be disappointed by this episode, as I will not show code yet, but by the end of it, you should understand when to use what and how to manage customer expectations. For the how-to bits, I invite you to join me at episode 2. Okay, let's get started with machine learning. Machine learning mostly helps you deal with predictions and anomaly detections in a supervised or unsupervised way. Supervised learning uses labeled training data, meaning data that has been annotated by human agents. As an example, we could have a sample of past loan requests with all their inputs, such as salary, age of the requester, and their corresponding risk estimate for the bank. Training a model with such data would help you predicting risk for future loans. On the other hand, unsupervised learning is mostly used to find common patterns among datasets, such as for instance consumer habits in terms of buying goods in Western Europe. Machine learning is using complex algorithms such as logistic regression, neural network regression under the hoods. The good news is that with Azure Machine Learning Studio and the Azure cheat sheet, you don't need to be a data scientist nor a mathematician to train and publish your own models. Azure Machine Learning Studio makes it relatively easy to get started. Alright, to better understand how machine learning may help, let's now see a typical machine learning scenario. A user reaches out to IT services and reports that his iPad is broken. It turns out that the service in charge of helping the user is a chatbot. In order to help reporting and categorizing the incident, the bot sends the verbatim, also known as the user input, to a trained machine learning model that returns the most probable incident category based on past categorizations performed by human agents for similar issues. According to the level of certainty, the bot automatically creates an incident in the ticketing system and informs the user about his incident and response times as defined in the SLAs. In this scenario, machine learning is key because it is used to predict the incident category based on the user input. Of course, in order to prepare and train this supervised machine learning model, one first needs to extract reliable historical data from the ticketing system, build and train our model with it. Long story short, deep learning is machine learning on steroids. Deep learning is combining huge amount of data with incredible new hardware capabilities, namely graphics processing units, which allow parallel processing of input data across multiple neural networks that mimic the human brain's way of working. Deep learning recently exploded thanks to GPUs, which make it possible to train models with billions of images and media files of any type. Deep learning is aimed at bringing to machines human beings' capabilities such as the vision, the speech, and the language. Here again, Microsoft comes with an offering called CNTK, but this time it's a different kettle of fish to get started with the toolkit. Indeed, it requires programming skills as well as data science knowledge and deep understanding of mathematics. You should know that Azure Machine Learning and Azure Cognitive Services already encompass deep learning techniques, so you should only use deep learning in some very specific situations. Here comes already our first important observation. Something I hope you already understood by now is that data is key to any AI process, and AI is not magic. It is crucial to understand that customers often have crazy expectations and tend to think that machines are learning on their own without any intervention. So whenever you deal with AI-related projects, you'll have to ask yourself about: is there any existing reliable data we can leverage? And do we have the necessary manpower to keep feeding our AI systems with fresh data? These two questions are key. NLP stands for Natural Language Processing, and this is a very hard task to perform as natural languages are incredibly complex. NLP helps extracting semantics out of a piece of text and make use of specific operations such as lemmatization, tokenization, partial speech tagging to identify each word and its role in the text. It also enables named entity recognition, which basically consists in extracting words of a specific type, such as persons, locations, dates, URLs, etc. NLP's practical applications include chatbots, search indexing and natural search understanding, automatic translation. We'll see a very practical example of using post tagging in a later episode. Given the previous disclaimer depicted earlier in tip number 1, Azure Cognitive Services bring AI at your fingertips as they are very powerful and shine by their ease of use. They encompass both machine learning and deep learning techniques and release you from the burden of having to understand the advanced underlying algorithm. But we'll see that some of them still requires you to bring your own data. Use them whenever you want to bring human being-like capabilities to your applications. In a nutshell, Azure Cognitive Services provide you with a large amount of services scattered over 6 main categories. The vision category helps you mining pictures and videos by extracting metadata and detect emotional patterns. Speech helps you envision voice-related scenarios. Language is probably one of the most interesting category whenever you need to build information from unstructured documents and whenever you want to improve human-machine interfaces. Knowledge is about reusing academic information as well as building knowledge bases. Search helps you improving any search-driven application. Labs are still at the time of recording this video in the discovery phase and are dedicated to early adopters. However, they can render interesting services such as calculating complex travel times and identifying the attractiveness of a location. On top of these categories, there is a key difference I want to highlight among the services. Some of them, such as the Face API, the Text Analytics API, the Bing Auto-Suggest API, are directly consumable without prior training and without you having to bring any data. You can directly throw your text to the Text Analytics API and it will provide you with a detailed analysis of your text. You can throw a picture to the Face API and you'll get the age, the gender and any kind of information about that face without any effort. Next to that, other services such as Language Understanding Intelligence Service, also known as LUIS, the Custom Speech Service, Q&A Maker, require to be trained with your business-specific information prior to be consumed. In other episodes, I'll spend more time in explaining these services as they require a little more effort, but they are by far the most interesting services. To make it more concrete, here are some typical usage scenarios of Azure Cognitive Services. It ranges from automatic tagging of documents and automatic routing of documents to spell check, improve end user search experience, creating chatbots, creating knowledge bases and more. So if you still wonder what's in it for me, I guess you all deal with documents and people who are too lazy to tag them properly. You probably have a lot of knowledge scattered everywhere in the company. Users complaining that they never find what they're looking for. If these things ring a bell to you, then you start understanding the value of Azure Cognitive Services. In the future episodes, I will be showing how to leverage Azure Cognitive Services through a chatbot. We'll route some documents from the chatbot, we'll launch intelligent queries from within the chatbot, we'll interact with the knowledge base, and much more. I hope you have a better understanding of the various concepts encompassed by artificial intelligence. Azure Cognitive Services are by far the easiest way of building smarter applications. I'd recommend you to look at them for every AI-related request. For the time being, you should use either machine learning, either deep learning, whenever it comes to predicting values and detecting anomalies. You can of course combine all the techniques together according to your requirements. Follow me on Twitter to get news about upcoming exciting new episodes. Please also feel free to rate and comment this episode to share ideas I could tackle in the next episode.